Over the last 15 years, the cost of reaching orbit has dropped by an order of magnitude. In 2010, solar hardware cost 200 rupees per watt. Today, it's closer to 10. That same scaling effect is hitting the rocket industry, leading to a world where launches happen almost every other day. This current state of the industry is dominated by massive vehicles from companies like SpaceX. These act like an orbital metro system. They are designed to carry enormous amounts of cargo to generalized, highly trafficked hubs. If your satellite needs to go to a standard orbit, these trains are the most efficient option available. However, the hardware itself is shrinking. 90% of modern satellites now weigh under 300 kilograms, roughly the size of a suitcase or a mini fridge. These smaller devices have highly specific mission requirements. To maximize Earth coverage, they need to be dropped at unique equatorial angles. A massive metro rocket cannot easily deviate from its primary flight path to drop off a single payload at a custom coordinate. This creates a significant gap in the market. Thousands of capable small satellites are left waiting for a ride because the launch industry lacks a point-to-point delivery service that can take them directly to their necessary orbits. In 2018, 2 engineers identified this lack of customized transportation as a massive business opportunity. Pawan Kumar Chandana and his co-founder were scientists at ISRO, India's National Space Agency. ISRO is known for its extreme engineering efficiency, having reached Mars on a budget lower than the cost of the movie The Martian. They left their secure government positions to start Skyroot, a private rocket company. At the time, this was a massive risk. Private rocket launches were actually illegal in India, as the government had never intended for a private space sector to exist. They were stuck in a cycle of circular logic. Without a private rocket to show the benefits of commerce, the government had no reason to open the sector. But without the sector being open, they couldn't legally launch the rocket they were building. They decided to build the hardware anyway, betting that the physical existence of the rocket would force a policy change. Their gamble worked, eventually triggering a total shift in Indian law and opening the country's private space economy. To reach space, a vehicle must fight Earth's massive gravitational pull. Most of a rocket's weight is fuel, and as that fuel burns, the rocket must separate and shed its empty tanks in stages. This is the only way to carry a payload all the way to orbit. Massive rockets have the luxury of scale. Because they carry so much fuel, they can afford the extra weight of thicker walls, redundant safety components, and heavy backup systems. On a small rocket with a 300-kilogram capacity, every gram counts. There is no room for redundancy. Engineers have to optimize every single part of the machine, which makes building a small rocket significantly more difficult than building a large one. Solving this optimization problem acts as a technical filter. If a team can master the brutal physics required for a small, lightweight vehicle, they prove they have the engineering discipline to build much larger systems in the future. This technical pedigree allowed the founders to raise 10 crore rupees in less than an hour. The investment wasn't based on a complex financial sheet, but on their ISRO background and the clear demand for a customized launch service. Skyroot functions as a premium logistics company for space. Clients pay for a bespoke ride, booking the entire rocket to ensure their satellite reaches its exact intended coordinate. This chart breaks down the revenue potential. A single successful launch at premium rates can bring in 100 crore rupees. If the company scales to 20 launches a year, that creates a 2,000 crore revenue stream. This niche model has lower barriers to entry than the mass transit giants. While building any rocket is expensive, focusing on specialized logistics allows a company to reach profitability without needing the multi-billion-dollar infrastructure required to compete with the world's largest launch providers. It proves that you don't need to build the biggest rocket to win. By solving a high-value logistics problem, Skyroot created a high-margin business in a sector usually known for burning through capital. This raises the question, why are companies willing to pay a premium for specific orbital drops? The answer lies in Earth observation. These satellites use specialized cameras and radar to monitor the planet 24 hours a day, but they only work effectively if positioned at very specific angles over their target regions. In precision agriculture, these cameras are so sensitive they can detect temperature differences of 0.1 Kelvin. This allows farmers to see when leaves are becoming dry or stressed before it's visible on the ground. telling them when and where to irrigate. The same technology helps the fishing industry. By mapping potential fishing zones based on ocean temperature and food supply, satellites help fishermen save billions of dollars in fuel by directing them straight to the most productive waters. Customized space logistics is a tool for terrestrial optimization. It provides the data infrastructure required to manage food and energy resources more efficiently across the entire globe. The next phase of this economy involves moving AI data centers entirely into orbit. While transmitting that data back to Earth still faces significant latency hurdles, the energy incentives are becoming hard to ignore. In space, you get 7 to 8 times more energy per unit area than on Earth. Data centers can have constant solar exposure and zero-cost cooling. But building them at scale depends on lowering the cost of customized, frequent launches to specific orbits. For Skyroot's founders, the ultimate mission is the expansion of human civilization. They believe that as Earth's resources become more strained, moving our heaviest industrial and computational needs beyond the atmosphere is the only way to sustain a growing population. By building hardware when it was still legally impossible, the founders shifted India's space program into a commercial era. Their work shows that orbit is no longer just for scientific research. It is a practical logistical tool for solving resource challenges on the ground.